I'm Michael Krasny, and I want to welcome you to another live episode of our weekly global podcast, Gray Matter with Michael Krasny. We do deep dive interviews each week with national and international experts, authors, journalists, artists, entertainers, and opinion shapers, which include your questions and comments. And we also invite those of you who have not yet done so to join this podcast by becoming a member. We cover a wide range of intellectually stimulating and engaging topics and issues, distinguished by high-level content and technical excellence. And to become a member, simply go to graymatter.show, and that's gray with an E. In this episode, we've invited back astronomer Andrew Fraknoi to discuss the total solar eclipse and the whole fascinating phenomenon of eclipses. On April 8th, the moon will cross entirely in front of the sun, a rare astronomical event which won't occur again until August 2044. And for those who see the total eclipse, the sun's corona, a majestic sight, will be revealed, and that promises to be very exciting. The recipient of many honors and awards in his field, Andy Fraknoi was for years the chair of the astronomy department at Foothill College, and he continues to teach at the Fromm and Osher Lifelong Learning Institutes in San Francisco. He also serves on the board of trustees of the SETI Institute, that's Searching for Extraterrestrial Intelligence, which prompts me to put in a plug for episode 51 of this podcast with Harvard Professor and ET hunter Avi Loeb, who we ought to set up in a debate with Professor Fraknoi. But also episode 23 of Gray Matter was with space medicine expert Dr. Vienna Tran, and Andy Fraknoi was the guest on our sixth episode. So let me welcome back the lead writer of the most widely used astronomy textbook in the United States and someone who is serving now on the National Eclipse Task Force of the American Astronomical Society, Andrew Fraknoi. Good to have you again.
Oh, thank you for such a gracious introduction, Michael.
Well, you deserve the grace, and we're going to have, I think, what should be a very lively and enlightening discussion. And I ought to mention, time permitting, we're going to talk a lot about eclipses, but time permitting, I want to talk about the brightest optic thing we have seen in a long time, maybe the brightest ever, going about 12 billion light years, as well as astrology, because Andy has been a long debunker, and if you are a believer in astrology, hold on to your seat on that one. And Professor Avi Loeb, who Andy has some, shall we say, serious disagreements with. This is all time permitting. But right now I want to talk about eclipses. And let me just say by introduction that for a long time we could not predict eclipses, but now we can. In fact, we can predict them, about 1,000 years ahead of time. And for a long time, we didn't know what eclipses were all about. We thought dragons in China, ancient China, dragons were eating up the sun. There were theories about eclipses that had to do with all kinds of bad omens and so forth. We're going to find out what eclipses are really about, and we have Professor Fraknoi to help us do that. But this is a once-in-a-lifetime event. NASA says 99% of the United States will be able actually to see a partial or total eclipse, which means 32 million people will actually probably see the total eclipse or something that's very spectacular. And let's talk first about prime places to view, the best places to view.
Well, the nice thing about the eclipse on Earth is the shadow that the moon creates when it gets in front of the sun. And if you're in the darkest part of that shadow, then you see the moon completely covering the sun. And that path moves as the Earth turns. And so the result is that there will be a path, a strip of land starting in Mexico and going northeastward, mostly through Texas, then the Midwest, into the upstate New York area and New England. And that strip of land, about 100 miles wide, is where the dark shadow hits the Earth. And if you're there, you can see the sun completely blotted out by the moon. So that's where eclipse enthusiasts from all over the world are going, into that strip from Mexico up to actually northeastern Canada.
That path of totality takes us down to about the longest possible seeing of the eclipse, 4 minutes and a half.
So this is a more generous eclipse than the one we had in 2017. And so if you're in the middle of the path, in the middle of where the dark shadow is, you can see over 4 minutes of the moon covering the sun. And if you've not seen that spectacular sky event, it's really worth seeing sometime, because what happens is that the moon slowly but surely covers the disk of the sun, and it actually becomes like night in the middle of the day. The stars come out when the sun's light goes away. Animals are confused. They don't know what to do because it's not the same schedule in their eyes as it is in their stomachs. And it's an awesome, eerie sight. And as you mentioned, then the faint atmosphere of the sun, which is much too faint to be visible normally, becomes visible. You can see flickering lights around the sun, and it's just a lovely sight to behold.
You can also see all that chromosphere as well as, I think, the corona, right?
Right. So the corona is the outermost part of the atmosphere. The innermost part, as you say, is called the chromosphere. And that you need binoculars to really distinguish the different parts there. But that's the other amazing thing is whereas it's not safe to look at the sun anytime even a small part of it is showing, during those 4 minutes, it's perfectly safe to look at the eclipse sun with binoculars. And with binoculars, you can really see the details of the flickering atmosphere around our star.
You've been doing something, I know, with the Moore Foundation about eyeglasses, special eyeglasses.
Right.
And please not only explain that and how they're available and what you need to do without getting any harm. But what is this about a colander on your head?
Okay. Well, let's separate those two questions. So let's first tell our listeners that separate from those 32 million who will see the total eclipse, we calculate that 500 million people in North America will see a partial eclipse, where the moon doesn't fully cover the sun, but it looks like there's a big black bite taken out of the sun. And that's the eclipse where you have to be careful about your eyes, because the sun is still showing, and staring at the sun can damage your eyes. So there is a special kind of plastic material which can cut down the excess rays, if you will, of the sun and make the sun safe to look at. And there are several manufacturers who make this plastic material into glasses. And we thought to ourselves, 500 million people are going to see this eclipse, even if some people have bad weather and they can't see it, and some people are too busy at work or in school. That's still a lot of people who need eye protection. What can we do? And so we went to the Gordon and Betty Moore Foundation, and they very kindly funded 6 million eclipse glasses, which are being distributed to 13,000 public libraries nationwide in the United States. Now, not every library in the country has it, but many do. Some are already out. The glasses are gone. Others are saving them for April 8th, the day of the eclipse. But if you would like a pair of those glasses, your first move should be to gently get in touch with your library. The librarians don't like being yelled at when the glasses are gone. But if you could gently get in touch with your library and ask them, do they have glasses? Also, many of the science departments, astronomy departments at local colleges may have glasses. Science museums probably sell these glasses in their gift shop. So there are a number of ways you can get these protective glasses and then look at the partial eclipse without hurting your eyes. But let's say you can't. This is where Michael's great notion of the colander comes in. Supposing you can't get these glasses and you still want to see the eclipsed sun. My favorite way of doing that is to project a shadow image using a household colander. You know, the big round thing that you wash dishes and spaghetti in. Not dishes, I'm sorry, you wash salad and spaghetti in.
Well, you can try washing dishes in it, but I don't know if it's very practical, yeah.
This is my being too eager to do the dishes, obviously. But anyway, if you get one of those colanders and bring it outside with you, here's the deal. You stand with your back to the sun, and then you take the colander and hold it over your shoulder and angle it so a shadow of it is seen on the sidewalk in front of you. Every hole in that colander becomes a little pinhole projector and makes an image of the eclipsed sun on the sidewalk. So if anybody looks at that shadow on the sidewalk, they'll see many different images of the eclipsed sun. And as the moon moves in front of the sun, that image will change and show you how the sun is being eclipsed. And if you're standing in the middle of the street with a colander over your shoulder, your neighbors will surely come over and ask if you're okay. And then you can explain that you're doing this incredible scientific experiment and show them the eclipse on the sidewalk.
And what about ordinary sunglasses?
Absolutely not. Ordinary sunglasses are not okay. Swimming goggles are not okay. Even typical welder's glasses, not okay until you get up to number 14 or greater. So we encourage people to be really careful with their eyes and either get these glasses or project an image. Another way to project an image is to get a hand mirror, cover the hand mirror with cardboard, but cut out a hole about the size of a dime. So tape some cardboard to a hand mirror, but cut out a small hole, and then use that hand mirror to angle the sun's light onto a wall nearby. And again, you'll see a small but completely safe image of the eclipse sun on the wall, which people can look at, more than one person can look at. And practice both with the colander and the hand mirror if you do this. Practice ahead of time so you're not nervous the day of the eclipse. That's my veteran's suggestion.
And citizen scientists can play a role here too. I mean, NASA has actually trained about 100 of them, right?
That's right. Well, there are actually many citizen science projects that are happening for the eclipse. For example, some people are noting what the reactions of animals are to the eclipse, what happens in terms of the sounds they make, of the movements they make, to get kind of a biologist's eye view of what the effect of the eclipse is on wildlife or even on domesticated animals. Other people are measuring sound levels during the eclipse or light levels, to what degree our polluted atmosphere really allows things to get dark. And so there's an interesting website that I'd like to recommend, Michael, which is put together by the American Astronomical Society, which is our professional organization. Just like doctors have the American Medical Association, we have the American Astronomical Society, the AAS, as we call it. And they have a website, eclipse.aas.org. Eclipse.aas.org. And if you go to that, it has all kinds of information about safe viewing, about where to get glasses and filters, about what different groups around the country are doing, what each state is doing. So if you're really interested in the eclipse, that can be a sort of one-stop shopping website where a lot of information is concentrated.
There's still a lot, when you talk about biology and animals, there's still so much for us to learn from eclipses. In fact, physicists don't know about the mass that's being lost from the sun every time there's this kind of eclipse. This is one of the enigmas that remains.
Well, we do. The nice thing about observing the sun these days is that we don't just need to rely on the eclipse to see what the outer layers of the sun are doing. We can actually create an artificial eclipse in our telescopes, put a big disk up to cover the sun, and then look at what the sun's atmosphere looks like. So while it's absolutely true that the sun's atmosphere was discovered during an eclipse, and many things about the sun's activity and how much material comes out of it, just the way you say, that was all discovered during eclipses of the past. Today, we scientists are not as sort of dependent on the eclipse to learn about the sun's outer layers. Nevertheless, we still have an incredible fondness for what an eclipse looks like on Earth.
And still want to know those things, despite, I mean, that's what being a scientist is all about. And we're all about taking questions, as you know, and some good ones coming in here. We'll take as many of your questions as we can. Let's start with Reed, one of our regular followers who always has good questions. And he wants to know, will any astronomers go in airplanes to experience the eclipse, and will it be visible from the ISS? And then he also says, I'll be in Indiana for this event, and I've had it planned for years. My questions are, how fast is that zone of totality moving across the country, and what will the experience be like if the skies are cloudy?
Yes, so that's a lot of questions. Let's see. So will astronomers be flying on airplanes? Yes, some often do that, although again, because we've now been able to create artificial eclipses, we don't have quite the pressure to observe the eclipse itself as we used to have in the past. But it's definitely true that the eclipse is observable from space. I don't think the International Space Station will be in the right position. We asked the NASA representative that on our recent call, and their thought was that they would have known if the space station was going to be doing that, and so we suspect that that's not going to be in the right place. But if you look on the web, you can definitely see pictures of the dark spot of the eclipse in previous eclipses on the Earth as seen from space. So those are very interesting pictures to look at. Now, you also asked, what speed is the shadow moving? And that varies depending on where in the eclipse we are. But it just so happens, Reed, that I have it for Indiana. I don't know why I happened to write that down, but I did.
You're not a Hoosier, are you?
No. I'm a New Yorker from way back, but it just turns out I have that number. And at Indianapolis, the moon's shadow will be moving at 1,995 miles per hour. 1,995 miles per hour. Please don't do that on your local freeway yourself, but that's what the moon will be doing.
And thank you for the questions, Reed. And again, we try to get as many of your questions in here as we can. Bill wants to know, how will the eclipse look in Northern California?
Well, so here's the issue. Here in Northern California, we only get a partial eclipse, and about 45% of the sun will be covered. And, that's not bad, but it's not as good as 100% or 90%. But we will still have a good bite taken out of the sun. And let me give the figures for the Bay Area. So the partial eclipse here in San Francisco begins at 10:14 a.m. And the eclipse will be at its maximum, where the biggest bite is taken out of the sun, at 11:13 a.m. And the moon will be completely off the sun at 12:16 p.m. So this is it. First thing to note about those times is it's more than an hour between the maximum and the beginning and the end. And so this isn't something where you have to catch it right away. You have some time to come out from your workplace or school place, get your glasses in place or colander in place, take a look at it for a while, go back, come out again. It's 10:14 a.m. to 12:16 p.m. Gives you a lot of time to observe this celestial phenomenon.
Now, Andy, something I can't understand, perhaps you can help me, as you have with many of these things in the past. You could be anywhere in the solar system, standing on any planet, and you can't see a total eclipse. Why is that?
Oh, this is great. A great question, which has been a research subject for astronomers for some time. So we ask ourselves, what a remarkable coincidence it is that as seen from Earth, the moon can exactly cover the sun. After all, the moon is a much smaller body, but it happens to be closer to us. The sun is a gargantuan object, something like 1,000,000 miles in diameter, but it's much further away. And it just works out that the two happen to be the same size as seen from Earth. Now we ask, does that happen with any other moon-sun combination in our solar system? If you were on Mars, would either of its moons be able to cover the sun? How about Jupiter, any of the other planets? And the answer is no. On no planet is it exactly the same. Sometimes the moon can be bigger than the sun, sometimes it can be smaller than the sun, but we're the only place where there's this exact coincidence. So I want to congratulate your listeners in their good taste in being born on Earth where such a thing is observable.
And we're kind of alluding to this before, but I wanted to get in a little more detail with you in depth on this. And that is, what have we really actually learned about the sun from all these eclipses? What do we know about the sun now that is especially valuable to us?
Right. So in the early days of doing scientific studies of eclipses, and by the way, there are wonderful books available on some of these early eclipse expeditions where we were just learning how to observe the sky scientifically. in the 1800s and so on. But one of the first things we learned is that the sun did have an atmosphere. Just like the Earth has a thinner layer around it, the air layer, so there's a layer of thinner gas around the sun. Eventually, we learned that the outermost layer of the sun is actually hotter than the surface of the sun. This corona that you talked about, the outer atmosphere, is at millions of degrees, much hotter than the surface of the sun. And that seemed a real mystery. How could the atmosphere not be cooler than the sun? After all, heat is now escaping from the sun. And the answer turns out to be that the sun is highly magnetic, and it's magnetism, the power of magnetic energy, that's heating up this outer layer. And we never knew that until we were able to make measurements during an eclipse.
And Susan from Boulder, Colorado wants to know, how often do eclipses happen on Earth? Thank you, Susan.
That's a great question. So one of the things that people often ask when they have time to think about an eclipse, and I am going to answer the question, but I'm going to answer a different question first. Bear with me. But one of the things people ask is, well, wait a minute. If I think about the moon going around the Earth, the moon goes around the Earth once every month. It's actually, month comes from moons. So if the moon goes around us once a month, isn't it always going to have a time when it's near the sun in the sky? Shouldn't there be an eclipse every month? And here's the interesting additional fact you need to know. The orbit of the moon going around the Earth is actually tilted a little bit. It's not in the same plane, not in the same direction as our orbit around the sun. So most months, the Earth, as the moon goes around the Earth, the moon is either above the sun because of this tilted orbit or below the sun, and it can't eclipse the sun. And it turns out that the two orbits, think of them like hula hoops, the two orbits only cross in two places, and those are about 6 months apart. So every 6 months, we have what's called eclipse season, when the moon is not above the sun, not below the sun, but actually crossing in the same plane as where the sun is. And so we have eclipse possibility every 6 months. But not every time do we get a total eclipse. Sometimes we only get a partial eclipse. Sometimes we get a ring of fire eclipse like we did in October. But every once in a while, every couple of years, somewhere on Earth, there's a total eclipse. The problem is most of the Earth's surface is water. And so most of the time, the total eclipse is visible in a path which happens to be mostly over water. And only rich people who can rent boats can get to see that eclipse. So it's nice to have a democratic eclipse like this, which comes over land, which covers North America, and which gives more of us a chance to see an eclipse.
And this is the first total eclipse in, 7 years?
Yeah, in the United States. It's the first one since 2017. And you mentioned that the next eclipse visible anywhere in the United States will be 2044, but that will only be visible in the very remote corners of the Pacific Northwest. And the next one to cross the United States will be in 2045. So if you want to see an eclipse like this, the next chance is 2045. I'm not sure I'll be around no matter how many vitamins I take. And so this is a good thing to be thinking about now, because we won't have a repetition in our country for a while.
Well, for those who are listening to us or have joined us from other parts of the world beyond the United States or Canada or Mexico, still welcome your questions. And here's one from Pittsburgh, Pennsylvania. Josh wants to know, what advice can you give to enthusiasts when selecting their viewing location? What can be seen in a city environment versus a rural setting?
Right. So this is a good question. I'll answer your specific question and then I'll generalize. First of all, it's really important for the sky to be clear. That sounds silly, but that's the biggest problem that people have with eclipses. They gather somewhere, and then that day it's completely cloudy, and they are never able to see it. Here in San Francisco, there's always the danger that we have fog that will linger, and if it's completely foggy, you won't be able to see the sun. So number one issue is think about the weather, get weather predictions, and try to be in a place where it's clear. But more generally speaking, the nice thing about the eclipse is that it's, as I say, very democratic. It happens all over, whether it's a city or rural location. During the day, you don't have the issue of city lights, although some lights may come on when it suddenly becomes dark during a total eclipse. Some automatic lights may come on. It's not that city lights are going to ruin the view for you. Wherever you're located, there are only two things really to pay attention to. One is the weather, and the other is that where the sun is when the eclipse is happening is not blocked by trees or big buildings. If you're in Manhattan, you have to be really careful that you don't have a big building in the way of your view of the sun. So the thing I always tell people is go the day before or a couple of days before to where you expect to be and check out your view of the sun a couple of days before. If you can see the sun a couple of days before, you'll see the sun on April 8th, weather permitting.
And let me thank Josh for the question. Can you say something about the misconceptions and the concerns that many people have about eclipses, the dangers, for example, in many people's minds?
Yes, absolutely. I mean, as you mentioned at the outset of the program, eclipses happen frequently enough that almost all cultures had eclipse stories and eclipse mythology, even in ancient days. And you mentioned one of my favorites, which is in parts of Asia. There was the story was that when an eclipse happened, there was a fierce dragon that was trying to eat the sun. And we on Earth could participate in the celestial drama by scaring the dragon. So people would bring pots and pans outside and bang them together as loudly as possible to frighten that dragon. And you know what? It always worked. And the dragon released the sun and it came back. And so that tradition still lingers in some Asian communities and countries where they'll go out and make a lot of noise during the eclipse. And I think that's a festive celebration. Now what we're hearing is that in some places, the story has gotten around that eclipse rays, whatever those are dangerous for pregnant women. And this is absolutely, there's no basis for this. There are no eclipse rays. The only rays we get from the eclipse are the rays of the sun, which come to us all the time anyway. So there's no danger and there's no special danger for pregnant women, but it's so easy to frighten people who are worried about an unborn child, right, and making sure they're born healthy, that these myths are easy to spread. But let me very clearly say, there's no danger to pregnant women. There's no danger to children, except that during the partial eclipse, children need to be taught not to stare at the sun with unprotected eyes. You need to be sure that children, even if they're really interested in what's happening, have proper protection, or they look at a projected image like the colander.
I got to take a quick detour here to ask you, do you see astrology in that same category as stories like the dragon?
Well, astrology is a complicated topic. I like astrology. You're going to laugh at this, but I like astrology because we think that astrology was actually one of the reasons astronomy began. Astrology is the idea that the position of the celestial objects, especially the bright ones like the sun, the moon, and the planets, their position at the moment you were born has some profound predictive effect on your life. That if you were born when the sun was in this part of the sky and the moon was in that part of the sky, you'll be a great success. And if it was in some different part of the sky, you'll be a complete loser. This notion has no basis in fact, but it's very intriguing, particularly in the early days of civilization when people felt so unsure about what cosmic forces affected us, that this astrology idea was very attractive, and it caused people to really keep track of celestial objects. And we think that was one of the beginnings of astronomy, is that people kept track of celestial objects at first for its predictive value, but then eventually they said, well, forget that part. There's no consistent effect of the moon being in this part of the sky and the moon being in that part of the sky. Forget that part. But it's really interesting to keep track of the moon and to keep track of what's happening to the planets in the sky. And astronomy arose from that. And so we're grateful to astrologers for that. But today, when we've done test after test of astrology to see if there's anything to the predictions that it makes, and it has failed every single scientific test, there's no reason now to worry about the effect of the planet's positions on your love life. Just worry about the nice spectacle they make in the sky.
Years ago, I decided to do a strange little task that involved making couples who were born on the same day. Now, astrologists will tell you you have to know the exact minute and the place and so forth. But I thought, what kind of couples would I come up with? Because they have the same horoscope. And these were the strangest couples one could possibly imagine. Richard Nixon and Joan Baez always remained in my mind. And I may have told you the story about when I interviewed Carl Sagan many years ago and an astrophysicist, and we were talking about wormholes and all kinds of things like that. And suddenly I said, we haven't had any women callers. We're going to go to a woman caller here in a minute, I hope. But I said, here's Gail from Walnut Creek or whatever. Go ahead, please. Our first woman caller. And she said, yeah, I just tuned in, but I wanted to know if my moon is in Sagittarius. And anyway, you should have seen the expression on Sagan's face. I mean, it was priceless. Just wish I had had my camera handy. So this is Dustin from Boise, Idaho, who says, with all the celestial dynamics, how long have total eclipses happened? And will they happen forever on Earth? Presuming Earth remains forever. Yeah.
A very, very interesting question. And this may come as a shock to some of our listeners, so hold on to your seats. But in the past, total eclipses were not possible. And in the future, total eclipses will not be possible. So let me tell you the story. We now know that when the moon formed, it was formed in such a way that its energy interacts with the Earth. Its motion energy interacts with the Earth. And the two bodies exchange energy very, very slowly over hundreds of thousands, millions of years. The moon is actually getting further from the Earth. Its orbit is getting larger and larger. So in the past, the moon was closer to us, and in the future, the moon will be further away from us. Again, that's not going to happen over human lifetimes, but in the long run. So in the past, when the moon was closer, it more than covered the sun, and the outer atmosphere of the sun would not have been visible during eclipses. The moon would have really covered up the whole zone around the sun. And way in the future, the moon will be so far away that it won't be able to totally cover the sun at all, and we'll always have a ring of fire kind of eclipse and an annular eclipse where the sun is still showing, and again, the atmosphere of the sun won't be visible. So all of our listeners are to be congratulated not only for the location they chose to be born, but for the time they chose to be born, because you are here now just when total eclipses are possible.
There's a question from one of the members of our great team. Chad wants to know, from where would you have the best view of the moon's shadow sweeping across the country at 1,000 miles per hour, and who's floating way up there to capture that video?
Well, as I say, sometimes we do have what we call space assets. That's the NASA term. Space assets that are looking down. We have weather satellites that have photographed this in the past, and I imagine they will try to photograph that again. As we said at the outset, it doesn't look like the International Space Station will be in the right position for this. And there aren't that many people up there these days other than the International Space Station. That's what the rocket that SpaceX tested yesterday eventually wants to do, is get people up there. But so right now we have mostly unpersoned telescopes that are looking down on the Earth, and they do show us the eclipse shadow moving across whatever country the eclipse happens to be visible in.
You've been so involved in education, astronomical education, eclipse education, and so forth, and you seem to have at least access to what's going on throughout the country. What are educators doing, especially to prepare students for this? And what do we learn from what educators seem to be pacing themselves at?
Well, yes, that's a very exciting part of what I've been doing for the last year and a half. The same grant that we got from the Gordon and Betty Moore Foundation also paid for us, an astronomy partner and I, to train teachers. And there are other projects also training teachers. So we think there are now about 2,000 science teachers who have been trained as Eclipse secret agents. And they're going out and training other teachers and getting their schools and their school districts ready for the eclipse. We actually have a booklet for teachers that anyone can access. Let me mention that URL. It's not hard to remember. We put together a little booklet with all the eclipse information teachers need and teaching activities. It's bit.ly/eclipses for teachers, all one word. bit.ly/eclipses for teachers. If you go to that site, you'll get a nice little booklet that we put together for teachers, telling them all about what you can say about the eclipse, what diagrams you want to show your kids, what activities you can do, etc. So there are strong efforts. NASA has been doing this. The Astronomical Society of the Pacific has been training people. And so we do have our agents, if you will, out there trying to help students and audiences of all kinds, including you mentioned that I teach courses for seniors, and there are a number of us working with organizations of seniors to make sure they're ready to observe the eclipse as well.
Yeah, it's terrific all that you're doing. And that includes educating us on some other things that I wanted to at least broach. I'm talking about the brightest optic, this is a giant black hole that we know about suddenly, brightest optic ever observed 12 billion light years ago that I had mentioned.
Yes, so this is a remarkable discovery, and let me mention sort of what's behind it. So one of the key things we astronomers have discovered that is sometimes a big surprise to people who haven't thought about it is that the further out we look, the longer ago we're seeing. Say that again. The further out we look, the longer ago we're seeing, because the speed of light is not instantaneous. It takes a while for light from an object in space to get here. And so if something is far enough away, a star is so far away, we call it a light year, the distance that light travels in 1 year. If something is 100 light years away in distance, that means it takes 100 years for the light to get here. And that in turn means that the light is 100 years old. And the news we're getting in that light is 100 years old. If something is 1 million of these light years away, the news we get is 1 million years old.
And you're talking again about a light object 12 billion years away.
Right. So the discovery that you're asking me about is that we've discovered a number of, now with big telescopes, we've discovered that there are objects much further away than that, billions of light years away. And the discovery that we're discussing is about an object that we now know is 12 billion light years away, and we're seeing it as it was 12 billion years ago, which is only 1.5 billion years after the Big Bang, after the creation event. And yet it's brighter than any other object we've ever seen. It actually puts out 500,000 billion times more energy than the sun. It's just a mind-boggling kind of idea. And so we've been investigating what it is, and it actually turns out to be a super giant black hole, one of these places where gravity becomes so strong that it pulls everything in. It's actually a black hole which is eating the whole galaxy of material that it's inside, but at least the central region of it. You might think that black holes are black and we shouldn't have that be the brightest object, but it's the messy eating. It's the fact that it's consuming vast amounts of material. It's a young, hungry black hole that makes it so bright that it's as if there was a scream of energy from the stuff that's being consumed. And it's that scream of energy that's so bright. And that's what we're observing. And it's a wonderful object to put in the Guinness Book of Records. But for us, what's exciting is it shows that black holes like this were able to form very early in the history of the universe, 12 billion years ago. And that comes as a surprise. We thought it would take much longer for giant black holes like this, hungry black holes like this to form. But apparently the universe is quicker at getting organized than we astronomers thought.
Well, we've come to lots of surprises thanks to some of the telescopes that have been built. What do you say to people when they ask the question, what was before the Big Bang? Or how did the Big Bang get here? They often ask it in terms of search for a deity or a higher power, but it's still a valid question for astronomers who are trying to be totally scientific, right?
So I have to answer with a quick story. Apparently, the medieval religious thinker who we now call St. Augustine was once talking to his graduate students. Okay, he didn't call them graduate students, he called them acolytes. But he was talking to the young people around him, and one of them asked, "Oh, great Father, what was God doing before God created the heavens and the earth?" And the story is told that St. Augustine thought about this for a while and then came back with the answer, "My son, God was making hell for people who ask questions like this." So this is a tough question for astronomers because we think the Big Bang was the beginning of space and time as we know it. And without space and without time, how do you answer a question about before? So we think that science can only begin to answer things when the Big Bang happens. That's when the space and time and matter that makes up our universe was created. And this sounds to the average person like a lot of equivocation. All right, so you're too chicken to answer the question, huh, astronomers? And of course, astronomers are human, and they also wonder what happened before science can actually answer questions. And one answer is something called the multiverse, which for a long time was something only nerds like me knew about. But now, because of Marvel Comics, everybody knows about the multiverse. Like Doctor Strange goes into the multiverse. So the multiverse is the idea that the universe is just one possible pocket of space and time, and that there are other pockets completely remote and different from us, other pockets of space and time, other universes which exist in a much larger structure called the multiverse. And the multiverse has always been here. Our universe is a relatively young baby universe that formed in the multiverse, but there are other universes we're not in touch with that are much older, and this question then goes away.
Well, we know there are billions, maybe trillions of other universes.
Yeah, maybe. If in the multiverse theory, there doesn't need to be a limit to the number of universes. And the comic book characters take advantage of this because they immediately think, well, if there's another universe, there might be the same creatures in it, but with different fates. And that's, there was an award-winning movie, an Asian movie about all things happening all the time, that actually took that as its main plot point, that the same things are happening in each universe. And if you could travel between them, you could have different outcomes for the things that happened to you that you didn't like.
This is good grist for Andy's mill because he's now writing science fiction and he's got 7 published stories. Last time we talked to him, he had published his first science fiction stories. One of our listeners wants to know, where will you be for the eclipse?
Well, that's classified. But we made reservations to be in Texas, which astronomically, and this is something important actually we should mention, that the weather predictions for the eclipse path vary tremendously. I mean, April in the United States is often a complicated month for weather. And although it's very hard to generalize, what the weather experts have been saying is the further north you go in the eclipse path, the more likely it is to be cloudy. And that's not something that you should bank on necessarily. Each location has its own kind of weather. But just in general, the further north in the eclipse path, the more likely clouds are. So most people who are real eclipse fans and have studied for this for years are saying you got to be further south in the eclipse path. So one place that the eclipse is really good is Mazatlan, Mexico, but I'm told that's completely sold out. That's a relatively small resort town. And then places in Texas, near Dallas, near Austin, those are good places to be for the eclipse because the weather predictions are not as bad as further north.
Here's Josh again from Pittsburgh. Says, Andrew, do you plan to perform any optical measurements during the observation? Are there specific light scattering interaction activities we can attempt during this rare event? And what information might they reveal about the light source? Thank you, Josh.
That's a great question. I don't plan. When I go to eclipses, there are these 4 minutes to be dazzled. And I try really hard not to do anything for those 4 minutes except to look at the beauty of the sun, to look around the environment, the eclipsed sun with the halo of light around it. It's unearthly, and you shouldn't be doing, unless you're really serious about the science, you should be enjoying the view. But as Michael mentioned, there's a lot of citizen science that's going to happen around this eclipse. And there are many experiments, and I mentioned that website earlier, eclipse.aas.org. That Eclipse website has a separate page which lists and links to every citizen science experiment that's available, that's being done for this eclipse. So if you know someone who'd like to participate in some part of science for the eclipse, go to that eclipse.aas.org website, go to the page on citizen science, and you will learn about the many different experiments.
What warnings or caveats are coming out about the eclipse, for example, from emergency management services or from your astronomers?
Right. So this is also a serious issue. If you go to Dallas for the eclipse, to see the total eclipse, well, Dallas is a big city and they have lots of tourists, so they're kind of prepared. There are hotels, there are stores stocked full of food, etc. But if, as many people are planning to do, you plan to go to a small city, a town, a village on the eclipse path, they may not be prepared for the onslaught of tourists. So it may turn out that there aren't enough bathrooms. We astronomers are encouraging the emergency management agencies, for example, to bring porta potties, forgive me for bringing this subject up, but porta potties into the eclipse path. In 2017, one of the things we learned was we need more porta potties in the eclipse path.
Throughout the path of totality.
There you go. And the other, and more seriously, water, food, etc. The other warning that we're giving people is that when the eclipse is over, a lot of people want to drive somewhere right away. And in 2017, the highways were just absolutely jammed with people wanting to go somewhere else after the eclipse was over. So our advice is, if you go somewhere for the total eclipse, make sure that you have enough water and toys for the kids and sunscreen that you can stay in place for an hour or two. Don't get yourself into the traffic jam that forms so quickly. Give those people who are dying to get out of there time to go, and then slowly make your way to where you need to be. There's likely to be a lot of traffic just before the eclipse and a lot of traffic just after the eclipse. So make sure you're ready for that.
Well, as you alluded to earlier, there are going to be people all over the globe coming to North America, coming to the U.S. to see this eclipse, especially the total eclipse, and it's going to get pretty crazy and crowded, as those things often do.
Yes, and again, many places have made preparations. We've been working on this for 2 years, our task force and our work with emergency management agencies and small governments, and also even state governments. We've been trying to warn people. So there have been lots of preparations. State parks, national parks are prepared for larger crowds than usual. Many cities have put up signs and have websites, especially about the eclipse and where you can go and where you should not go. So my advice to people is, plan ahead. Don't leave decisions for the last minute. Whether you're looking at the partial eclipse and you want to just make sure the sun is visible, or you're planning to go to the full eclipse, the total eclipse, plan ahead, talk to, find out from the Convention and Visitors Bureau, if there is one, what eclipse preparations are being made, ask to see the websites that different towns have, search for the area where you're going to be going to see if there are local websites with more information. The better you plan and the more you think ahead, the more you'll enjoy the experience.
Why should it be so enjoyable? What is it about it, in your judgment, that makes it so exceptional and so extraordinary? I mean, seeing the corona by itself, seems to me to be pretty exceptional and pretty remarkable. But I hear what Andy Fraknoi has to say about this. You'll travel many miles to see this, and it's quite an experience from everything I've been told. I've never seen a total eclipse.
So I'll cite an even higher authority than Andy Fraknoi, which is Andy Fraknoi's wife. My wife, Lola, who is an artist. When we were first courting, I got asked to be an eclipse leader on an eclipse boat, on a boat that was going around the Hawaiian Islands trying to see the eclipse. And I asked her to come along, and she's an artist. She was a little cynical about, this is something for nerdy scientists. I don't know if I'm going to enjoy it. And we were able to see the eclipse from the deck of the boat where we were. And as soon as the total eclipse started, I handed her the binoculars so she could see the flickering lights around the sun. She could see the tiny flames of the hot energy, the hot material coming off the sun and falling back in. And as soon as she started looking through the binoculars, her expression changed, and she refused to give me back the binoculars for the entire time. She was so enchanted. As an artist, she was so enchanted by the changing view that she could see of the atmosphere of the sun. I never got those binoculars back, and that was a wonderful memory we have of our courtship. So there are people who are not scientists who really do enjoy the spectacular view of the sun's outer layer.
That's a sweet and very revelatory story. We've also got another good question from Harry in Topeka, Kansas. Thank you, Harry. Given that eclipses haven't always happened, do we know when totalities have been the longest or will be the longest?
That's a great question. So when you say totalities haven't happened, they have happened all through human history. I want to be careful that the process of the moon moving away is extremely slow. So throughout recorded history, total eclipses have been possible. But we've actually calculated, knowing you were going to ask this question, we've actually calculated what is the longest possible time that you can see a total eclipse from Earth. If the geometry of the shadow works out just right, what's the maximum? It's just over 7 minutes. So the longest eclipse you could possibly see is 7 minutes. Now, this is going to be, in the best case, if you're in the center of that eclipse path, this one will be 4 minutes, 4.5 minutes. So that's not bad, but 7 minutes is the longest you could count.
Another question, what optical tools enhance the eclipse experience for the viewer? How should one split the time between the instruments and looking around with the unaided eye? Thanks for the question.
Right. So here I should mention something. I want to say that I don't make any profit from this, and it's not a commercial announcement, but an astronomer friend of mine has invented something called solar snap. The biggest worry we have about photography and instruments for the sun, for the eclipse, is that these days most people think of a camera and they think of their smartphone. And if you took your smartphone and tried to look at the sun, it would be not good for you and not good for your smartphone. Normally, nobody would think of pointing their smartphone at the sun and looking through it. But during eclipses, enthusiasm sometimes overcomes common sense. So this device called Solar Snap is a little filter you snap over the camera in your smartphone, and it's an app that automatically adjusts the camera in your smartphone to make it possible to take a picture of the partially eclipsed sun. And he's tested it in many different situations, and it works. If you install it and make sure the app is installed, you can use your smartphone for eclipse photography. And some nice photos have already been taken of past eclipses. So Google Solar Snap, SNAP. It's available in many different places, science supply stores, museums, the same places that sell the eclipse glasses, particularly a company called American Paper Optics, also makes Solar Snap available. So if you're a smartphone fan, this is one way to get good pictures of the eclipse through your smartphone.
Your friend should be very grateful for that. Was quite a nice plug. Nice promotion. Speaking about promotion and plugs, I said earlier on that I was interested in hearing you give some response to episode 51 and Avi Loeb, the Harvard professor we did an episode with, all about his hunt for extraterrestrial life. And I know you have some skepticism, concerns, and everything. So can we get those on the record here before we conclude?
Sure. So Avi Loeb, as you found out, is a brilliant scientist. He has a tremendously strong reputation in his area of research. But recently, he's kind of veered off to become a little more gullible about reports of UFOs and strange objects. And there was a very unusual object that came into the solar system, which we now call Oumuamua.
It's a Hawaiian word.
Oumuamua. And it's the Hawaiian name for it. And it looked like it was some object that came from another star system, not from our own solar system, from another star system. And it veered through the solar system and then went on its way. And there was some indication that its path changed in strange ways as it went through the solar system. This may have been gas forming from it when it was near the sun. There are various explanations. One explanation is that it was an alien spaceship changing course. And that's what Avi Loeb has written a book about and has been all over TV and radio talking about. And we just have to say that we astronomers are a little bit skeptical, to put it mildly.
Yeah, you're pretty more than a little bit skeptical, I would say.
There are many perfectly reasonable scientific explanations for why Oumuamua changed course. It doesn't need to be a spaceship. But he thinks he's found remnants of a spaceship under the ocean, which oceanographers say is absolutely not the way to interpret that data. So I think he's trying to publicize the idea that there may be life out there. And we astronomers definitely agree with that there may well be life out there. Not so clear that they're coming our way or that they've been in our little cosmic neck of the woods. Much more likely that we'll find them through signals that they give off or factories that they put together around their star, which we can see with our largest telescopes. But I don't think the aliens have been here, and I don't think that Avi is on the right track.
Well, as I said to Avi, it's very possible, plausible, and in fact conceivable that we may be all alone and there may be no other life out there, but we'll have to wait and see what we can discover. Here's Lisa from San Francisco. Says, can you experience the eclipse if you are vision impaired? Is there a temperature drop?
That's a great question. The total eclipse does include a temperature drop, and there are actually Braille books about the eclipse, ways to prepare for the eclipse. NASA, if you go to the NASA, look up Eclipse and NASA and look up Braille books, there is a Braille book that NASA is distributing about the eclipse for people who are vision impaired.
I thank Lisa for the question. And what else, before we conclude here, do you want to give in the way of advice or wisdom to impart to us about seeing this total eclipse, experiencing it?
Well, there are two things I'd like to say before we stop. One is you were kind enough to mention my science fiction, which I'm really proud of. As a retired astronomer, I've ventured a tiny bit into your field and have written some stories that have been published. And I do have a website called Fraknoi.com, Fraknoi.com. For some reason, that URL was not in great demand, so I was able to get it. If you go to Fraknoi.com, you can read my astronomically based science fiction stories. And the other thing I wanted to mention is that about the eclipses, there's going to be a lot of discussion about schools. Should kids be in school? Should you keep them home? And my advice is to talk to the teacher early. If you're an eclipse fan, talk to your kid's teacher, get them the information in that Eclipses for Teachers booklet, make sure they're aware, and come to some mutual decision about giving kids a chance to at least see the shadow of the eclipse.
First, let me thank all of you who joined us for this live episode of Gray Matter with Michael Krasny, and all of you who will be joining us on Apple, Spotify, or on our website at graymatter.show. If you aren't yet a member of this podcast, again, I invite you, actually urge you to join by going to our website at graymatter.show. That's gray with an E. And you can find any previous episode there. Also invite you to email any reactions, thoughts, or recommendations you may have to me at mkrasny@graymatter.show. I want to thank our great Gray Matter team. That's Alex, Shannon, Chad, Cullen, Kevin, Jeff, and Colleen. And a special thanks to this week's special guest, Astronomer Andrew Fraknoi. Thank you, Andy.
And everybody have clear skies on April 8th. That's what we wish you.
Have a good week. I'm Michael Krasny.
Bandwidth for Gray Matter is provided by CacheFly at CACHEFLY.com.